Okay, so hi everyone. Today we're going to solve another problem, that is 380, LeetCode 380, insert, delete, get random in constant time. So we have to implement a randomized set class, right? This one, and randomized set. So this is a constructor, and then we have three main functions. So insert, it will have a value as an argument. So it will insert a value into the set if not present, returns true if the item was not present, right? Because if we are successfully able to insert it, then we'll return true. Otherwise, if the element is already there, then we are not inserting it into the set, then we'll return false. Similarly, if we have remove and the value is the argument, then if the value is present in the set and we can remove it because it's present in the set, then we'll return true. Otherwise, if it is not present in the set, then we won't in the set, then we won't be able to remove it from the set, so we'll return false. And the last function, that is a very main function, that is GetRandom. So it returns a random element from the current set of elements. It is granted that at least one element exists when this method is called. Fine. So this is a very good, I think this is the line which makes it medium. Otherwise, if we have like duplicate elements or this line was not there, then it could have been a hard problem. Now each element must have the same probability of being returned. So you cannot cheat the system by saying that by returning always returning the first or the last element of the set, because in that case the first element will have the 100% probability of returning, but the second element, third element, or the elements in between will, or the elements other than the first element will have zero probability of being returned. So this is the get random function. Now the thing is, you need to implement these functions all of them, that they are constant time, that they are taking constant time. So let's see how we can solve this problem. So for example, let's say that let's take this test case. So we have insert, remove, then insert. So we have insert 1, then remove 1, remove 1, and then we have insert 2. Okay, no. So we have insert 1, remove 2, and then insert 2, right? And then we have a get random function. Then we have remove 1 and insert 2. So we remove 1 and insert 2, right? And then we call random function again. So let's solve for this one. So now, like the very basic thing, because we have insert and removal, so everyone I think must have got the idea that we are using a data structure called map or a set. We can also use a set, but map is I think a better choice in this case. We can use set, by the way, but I think just for the follow-up, like how we can convert this to an constant time, I will be using the map. I will be using the map data structure for better understanding, right? So we have, let's say, insert 1. So I will say that at 1th position we have an element, and that is true. And then I say remove 2. So I will remove it from the, so remove 2, but 2 is not present in the map, so we'll return, so this is true because the element is inserted, but this case it's going to be false because we don't have that element which the test case is requiring us to remove. And then we have insert 2. Fine, we can insert 2 as well because it was not already present, so we'll return true. Then we have get random. Now out of these values I will return a random value, and let's say I have returned something 1, right? And then I say that remove 1. Now 1 is removed, which means 1 is not there. And then I say insert 2. So insert 2, 2 is already there, so it will be false and it will be true because we were successfully able to remove 1. And then I say get random, and I only have an option to return true, right? So this is TFT, TFT. Okay, so they have returned 2, I have returned 1, and then we have remove 1, so we are only left with 2, and we have 2. Okay, so this is how this function is doing. Now how can we implement the get random function? Because I think you have observed that in map, if we want to insert an element, then we simply mark it as true. For example, this is the element, then the value, this is the element as the key, and we mark this value to be as true, right? And it becomes available. But if we have to use the random function, how we can do so? So in C++, we can use an iterator which is pointing on yeah. So what I was doing is, if iterator, so we have, let's say, an iterator, right? Let it be ITT. So this is the iterator and it's pointing on map.begin for the first time, and we make a random function which is in the range of, so let's say we have a rand value which is a random value, and it's in the range by doing a modulus of map.size, right? And now we have got the random function, and what you will think is that we will just add this random value and we will get our value. No, because in iterator we cannot add the values as it is in a constant time, we need to increment them, which means that I will be using a while loop which is going to exhaust the random value and increment the iterator pointer and increment the iterator pointer till we have reached the random, till the random value is exhausted, and then we will be pointing on the map which has a random value. But this is not fine. Why? Because it's using constant time. On worst case or on average case, it will be using constant time. Sorry, not constant, sorry, linear time. But we are requiring, but by according to the question, we are required to solve it in constant time. So in order to do so, how we can do so? So let's use an array, right? If an array is like a very weird option to use right now, I will tell you why it's a good safe bet to use array in this case. So let's say you have this value that is 1. So you were given insert 1, then you were given insert 2, and then you were told to insert 3, and now they say to remove 2, and then they say to get random function, and then they say to erase 1, right? And then they say to get the random function, call the random number. So let's see how to solve this. So first of all, insert 1. By the way, these are the indexes of the array, right? And this is a dynamic size array, so it means that it would be changing its size if we are removing an element or inserting an element. So we have insert 1, and we will also be using a map, by the way. So this is our map right here, and this is our array. And let me remove this. Right. Yes, so now we have this map. Let's say insert 1, right? So we will insert 1 here, and what is the index where this is inserted? So the map will have the value and index pairs, so which means that 1 is inserted at index 0. Then we have I is equal to then we have insert 2, so we will insert 2, and 2 has the index of 1. Then we insert 3, so we will insert 3, and 3 has the index of 2. Now we have remove 2. So when we are removing 2, this is all done in, so I will tell you why we are using array and why we are swapping the elements, because we are about to do so. So when I say that remove 2, if I remove 2 from here, then I need to shift these elements, right? So it will be a bad case for me, because it will then get of linear time, because I'm shifting the elements on the left side. Rather than doing this, what I will do is I will swap this 2 values. So first of all, before swapping, I will change their indexes. So I will swap these 2 values, right? So if I swap these 2 values, 3 will be here, 2 will be here, and their indexes are changed. This is 2 is now 2 index, and 3 is on 1 index. And the last element that I have in my array, that is this one, would be popped out. So this array will become something like this. So this is 1, this is 3, and now 2 is gone. So we have 0 and 1, only 2 elements, because this is popped out. And when we have popped this element out, so we can remove it from the map as well. Now I say get random function. So this random function will give me some random number, let's say 1793, a random function, right? And the range that I have is the size of the array. That is why we are using the array, because now we have a proper range on which we can fetch the element in constant time, because this is an array and we are fetching the array based on their indexes. So 173 modulus of the size is 2, and this will give me the value as 1. So the 1 index is my answer, is the random value, and that is 3 is my random value. And then I say erase 1. Similarly, if I say erase 1, the same operation will be repeated. So I will swap these values. Now this is going to be 3, this is going to be 1, and their indexes will change. 1 is now having the index as 1, and 3 is now having the index as 0, right? And then I will pop this element, the last element, from the vector, and the vector will look like 3, 0, and now we don't have any element here. And then I have called, after removing 1, then I've called the random function. So the random function will give me some unique value, that is 69,420, and the range is 1. So this will return me the value as 0, right? And 0 is the, so this is basically the index of the element, and 3 is the value there. So I will say that for this random value 3 is returned, for this random value 2 is returned, and we will then be removing it from the map as well. And now we are done with our operations, and now this is all good. So let's see how we will be implementing it. So we need two things, and I think you know the what are those data structures. So first is an unordered map, right? And this map is used to store indexes, so I will call it as index. And then we also need a vector of int, that is nums, in order to store the nums. Then in insert function, so there are two cases first of all which can return true or false. So the first case is if there's an index value, and I will find if in indexes, because the value is the key, because the key of these index map is the value of the number. And if it is not present in, if it is equal to the end, which means that, so this line states that the element is present, right? So if the element is already there, then we will simply say that return false, because the element is present with us. Otherwise, if the element is not present, then we will insert it into the set. And what I will do is, so first of all, nums dot pushback, and it's very important to note here that we are not initializing the nums vector, because the size could be changing because of insertion and removal. So which is why we are using a dynamic array that is a vector, or we can also use a pointer to the dynamic array, but I think this makes sense. So nums dot pushback, the value, right? The value is now inserted, and index will have the value as the last value, last index, and that is equal to size minus 1. So this is how it's done, and then we will simply return true, that the value that you have told us to insert is now successfully inserted, right? Because if the element is already present, then we don't need to insert it again. So we can just return false, because this element is already there in the set, in the map. Now the tricky part is removal. So if the element, let's say if index dot find val is not equal to index dot end, then it's a good case for us, which means that the element is present to remove it is present for the removal, right? In this case, the element is present, is already present, therefore no insertion can be performed, but the element is present there, which means it can be removed. Otherwise, if the element is not there, then we cannot remove it, right? So the remove operation will be false. But now the element is present, and then we can remove it. So first of all, we need to change their indexes, because if we swap them already, then the last element will change and we won't be change their indexes. So index of, now let's take some variables. So the last element is equal to nums dot size minus 1, and the current element is the value, and index, int current index, or let's say current val index is equal to index of this value, right? And the last index is equal to, sorry, last index is there with last element, and I think that's it. So instead of saying last element, I will have the nums dot back. So this is the last element, right? And this is the last index, and that is nums dot size minus 1. Now, thing to note here that first of all we will change their indexes. So index of the last element, that needs to be changed. So last element, which was initially, last in nums dot size minus 1, that is the last index, but now it is equal to current val index, right? And when this is changed, so that means that we have successfully swapped them, and then we can swap them. Swap nums, uh, swap this. Yeah, so swap of current val index should be swapped with nums of last index, right? So after swapping, what I will do is nums dot, now everything is done. Fine. So we had this operation where we have, let's say, 2 having the value of 1 and 3 having the value of 2, and it was 0 initially for this case, right? Now, and the elements were like 2 and 3. Let's solve them. So first of all, we will swap them. So this is the first operation. We will swap their indexes. So 2 is now going to be 2 and this is going to be 3, right? And after swapping their indexes in the map, then we will swap them physically in the index array, in the, sorry, nums array. And this is going to be 3 and 2. And after this swap, we are going to pop the back element from the nums. And after popping the back element, I will erase that instant, erase that value from, so index dot erase that value from the map as well, right? Because we were erasing, so because after removing 2, we were also removing 2 as well. So yeah, that's it, and then we will return true. Okay, we haven't solved the get random. So get random is easy. We will just simply return the nums of, so I will call the random function. In C++ we have a default random inbuilt random function, and this should be modulus with the nums dot size. So nums dot size mean whatever is the value from the random, it will be in the range of 0 equivalent to x. Let's say the x is the index, the random value index, and smaller than nums dot size, right? So I think it makes sense. Now let's solve this. Okay, so let's submit it. Okay, so it is submitted and it is performing, I think, not so good but not so bad, so I think it's fine. Yeah, the memory part is basically okay. So this is 94, this is 97. Okay, there's not much difference. So yeah, this is it, and I hope the explanation was helpful. If you still have any doubt, you can comment it out in the comment section. We can obviously have a discussion around it. So thanks for watching, guys. Have a good day.